All right, hello again, Algebra 2 people. So we are beginning what's probably going to be the last big topic of the school year, and that is going to be about exponential functions and things that are called logarithmic functions. We'll get to those a little later on. But exponential functions, I've always enjoyed this part of Algebra 2 because it's really a very useful set of functions. Whether when you start, when you buy a car, if you have a car payment, having that payoff amount depends on an exponential function. When you buy a house, mortgage payments depends on an exponential function. If you invest in a stock market or Bitcoin or just have a normal savings account, those things are going to grow according to an exponential function. If you go into science, population growth, half-lives with radioactive materials, all those things deal with exponential functions. So we'll get into those as we go forward in this unit. But today we're going to talk about just what is an exponential function, what's the format of it, and some transformations, kind of the way we've always started the different units all year this whole year. So we start off, the basic kind of parent basic function is a times b to the x. I'm going to label a couple of these things. We're going to call the a the initial value. Or you can also call it the y-intercept, because that's what it is. That's the same thing. And then the b is going to be our base. Okay, now do notice our b is always going to be greater than 0. It's also not going to be equal to 1. So it's going to be some positive number not equal to 1, because if it's 1, nothing happens. It's just a linear function. Just a constant, kind of go from there. And then, so that's kind of our general format. When we talk about the domain and range, the domain of all of these things is going to start off with being negative infinity to infinity. When we get to actual, like, real life situations, we might restrict that domain a little bit because it's a time value. But for the most part, it's all real numbers. And then the range is going to be from 0 to infinity. Again, just based on 0 or higher. It will never be equal to 0. From there. So there's two basic types of exponential functions. So we have either a growth function or a decay function. And you see them both right here. So obviously a growth function is over time, you get more things. So that's your population growth, or if you're investing money into a savings account or long-term savings, it's going to grow over time. So when does that happen? Well, it's a growth function anytime the b is greater than 1. Okay, and it can be a whole number, it can be a fraction, whatever. Anytime that base is greater than 1, it's going to be a growth function. And then the opposite happens if b is less than 1, then it's going to be what we call a decay function. Okay, so that's like if a population is declining over time, or if you have a radioactive element and it's decaying over time, you have less of it there. That's the decay function. So that's when the b is between 0 and 1. So like 1/2 or 2/3 or 0.1 or whatever like that. And that's the same thing with like mortgage payments and car payments too. That's how you have, you're paying off the car over time. So that's going to be a decay function. So the first thing I want you to do is just pause the video real fast and look at these 4 questions and just identify them real fast as if they're a growth or decay function just based on that, on the value of the base. And we'll come back together in just about 5 seconds and run through those. So again, if the base is greater than 1, it's automatically a growth function. If it's less than 1, it's automatically a decay function. So number 1 would be a growth function. Number 2 will be a decay. Number 3 is also decay, 0.75. And number 4 is going to be a growth function. Sub number 4 is like 1.75. So again, anything over 1 will be a growth function. Okay. Now, transformations. We always talk about transformations. The thing to remember about the transformation of these things is a couple things. One, the base is going to be given to you. Okay, so that's not our traditional B value with like horizontal or vertical, horizontal stretches or horizontal compressions. That's not what that is. The base is going to be given to you. All we're going to worry about is the vertical stretch or compression or the horizontal shift or the vertical shift. Okay, now I'm going to switch my screens real quick to go over to Desmos just to show you, just to give you a quick demonstration of what these things are going to look like from here. So notice here's my exponential function. Okay, and notice that everything is just kind of one right now. So if I change my A, that initial value, watch this point. Watch the y-intercept as this changes to 2. So you see now it's 2, now it goes to 3. So it's that vertical stretch. The actual shape of the graph is changing because it's getting steeper and steeper. If it goes less than 1, it's getting compressed, so it's a vertical compression. And of course, if it's negative, it'll be reflected across the x-axis, just like we've noted to be for the different functions. The h and the k, just move it left and right. So we've known for a while that h, as it goes left and right, again, watch the y-intercept and watch how this point shifts. The shape of the graph is not changing. It's just the whole graph is being shifted left and right. And then the k value, notice what happens here. As the k goes up and down, again, watch the y-intercept. The shape of the graph isn't changing. It's just shifting that whole thing. Also notice the asymptote. These do have horizontal asymptotes. So as the k changes, the horizontal asymptote also changes. Okay? So that's your kind of overview of transformation. So how would I kind of write those things out? Well, your a value, again, and we've had this for different kind of functions, your a value is just going to change if it's a vertical compression or vertical stretch. If it's less than 1, that number in front, it's a vertical compression. If it's greater than 1, it's a vertical stretch. Okay? And remember, I said this a second ago, but we also, the other name for a is either the initial value y or the y-intercept. That's all that a is always going to tell you. Okay? And then your h and k, again, we're used to that too. Your k is just going up or down. So if it's plus something on the outside, it'll be going up. Minus something on the outside, it'll be going down. And remember, your horizontal asymptote is always going to be that k value. So every single time, if it's asked about the horizontal asymptote, it's just going to be whatever that k value is. And then your h, remember, that's in the exponent, and it's going to look backwards. So if you see x minus something, that's going to the right, that many units. And if it's x plus something in the exponent, it'll be going to the left, that many units. And of course, we can also have reflections. You won't see these very often in kind of normal questions in like real life situations, but in transformation land we can have them sometimes. So be able to recognize when that happens. If there's a negative value out front, in other words, a negative a value, that's going upside down. That'll be reflected across the x-axis. And if there's a negative up in the exponent, and this you'll see even more skeleton in all honesty, but if there's a negative in the exponent, it'll flip over the y-axis, which it turns out that just becomes an exponential decay function, because it just kind of flips everything upside down. Okay, so let's get into a couple questions about how to write transformation. We like going 2 different directions. So start with a verbal description of the function, and then write the actual equation. And then other directions, start with the equation and just list out what the transformations are. So I'm going to ask you to pause the video again. Notice we are starting just with the base of 2. So all of these things are going to look like a times 2 as our base, x minus h plus k. So I'm going to give you a couple minutes. So just pause the video for a few seconds, work these first 4 out, write what the equation would look like, and then I'll run through the answer here in about 10 seconds. Okay, so number 1, the exponential function translated 3 right and 6 up. Notice there's nothing about the a value, there's nothing about a vertical stretch or compress, so not even going to write it because it would just stay at 1. The base value of a is 1. So this is going to be the base of 2 translated 3 to the right, so that would be x minus 3, and then plus 6, just like that. And then number 2, vertically stretched by a factor of 3. So that's your a value. Or my base here is just given as 2. 5 left, so that would be x plus 5, and then minus 2 on the outside. Number 3, reflected over the x-axis and vertically stretched. So it would be negative 6, 2. Again, my base is going to be 2, since that was given in the problem. And then to the x power, don't forget the x, but it's not going left and right, so we don't need anything else up there. And then plus 7. And then the last one, vertically compressed by a factor of 1/5. So that's my a. My base is 2. Shifted 3 down, so again, there's no left and right going on there. Minus 3 on the outside. If it did say, oh wait, but it was also reflected over the y-axis, almost forgot, so there's a negative x up there with the exponent. Okay? How about the next type of question? So now we're going the other direction. So describe the transformations that were applied to the parent function 2 to the x to get negative 2 to the x minus 1 plus 5. There's 3 things going on there. What's going on? Well, the first thing I see is a negative sign out front. So that's reflection across the x-axis. And then I see x minus 1 is the exponent. That's shifting 1 to the right. And then plus 5 on the outside, that's a shift of 5 up. Excuse me. And the last kind of question you might see is one using more function notation. So the graph of f of x equals 10 to the x is transformed. Let's just say transformed. Little typo there. Sorry about that. Is transformed to create the graph of g of x equals f of negative x plus 1. Write the new transformed function and describe the changes. Well, the transformed function is just taking this stuff and putting it into where it is, right? So the negative x can just get plugged in there. So it'd be 10 to the negative x power. And then the plus 1 is just on the outside. So now we can just say, okay, what's going on? Well, my base is 10. That doesn't do anything. That just tells me what my base is. My negative x says it's reflected over the x-axis. Or the y-axis, I should say. Reflected over the y-axis. And then the plus 1 is just shifting up 1. So that is your basics of the exponential function and a little bit on transformations. We're going to get into the kind of the opposite function called a logarithmic function. We'll do that in the next video. As always, if you have any questions, feel free to come into tutoring. And until next time, stay safe.